Hey folks, welcome to Chem 11.2. Um, the first set of notes is really just going through just intro stuff. We're following along with the textbook format, so basically starting in chapter 1 and just going through kind of a what is chemistry overview. As we start to carry through the course, there's all kinds of different topics that we'll cover in grade 11 as we try to give you a broad range of all the different ideas behind chemistry that are out there. So just to start off with, welcome. And our first kind of question really is, what is chemistry? Chemistry is the study of the composition of matter and the changes that matter undergoes. And so overall, as we start to run through these slides, I encourage you to find something that works for you, whether it's pausing the video partway through and copying down the notes as you go, maybe taking down the key parts, words that might be bolded or different colors, things that stand out to you, just the key concepts, or maybe printing off the pages and going through and making notes in the margins, that sort of thing, and just highlighting what's there. So whatever works best for you to learn, that's what I encourage you to go through. So if we start to go through this whole idea of chemistry, we talk about compositions of things, how things are made, how things break apart, and reactions, as well as changes that matter can undergo. And from earlier, you actually would have discussed a little bit about what matter was in previous years. Matter is composed up of two different concepts. So then the key question becomes, so what is matter? Matter is anything that it first has mass and two occupies space. So anything that has mass and occupies space is considered matter. And if we start to look around even your current area where you're watching this video, everything that you can see has some sort of mass to it and has some sort of space that it's taking up. So even the air that we're breathing in, it has a mass, and it also occupies the space that's in the area. So whether it's a solid, a liquid, a gas, it all carries some sort of mass, and it also occupies a little bit of space. So because living and non-living things are made up of matter, chemistry can affect all aspects of life and most natural events that occur. So there's 5 traditional areas of study when we start to talk about chemistry, and we'll just go through kind of each one at a time. Again, whatever way you learn best, I would encourage you to try to use those strategies. So whether it's jotting things down or going through and making notes on the side, something where you can kind of refer back to the information. So first is organic chemistry. It's a study of all chemicals that contain carbon. So carbon is an element on our periodic table. It's atomic number 6. And organic chemistry ties to anything that has carbon attached to it. There's entire courses that are dedicated just to organic chemistry, as well as full fields of work that deal with organic chemists and different applications of them. Then you've got inorganic chemistry. So organic would contain carbon. Inorganic, study of all chemicals that do not contain carbon. So one is a field of study with everything carbon-based. And inorganic chemistry, study of all chemicals that do not contain carbon. Biochem, study of processes that take place in organisms, so in living things. It's biology and chemistry kind of mixed together. Analytical chemistry focuses on the composition of matter, so how things are made up, and the different proportions, the different rates that things are made up in. And then we've got physical chemistry, and so an area that deals with the mechanism, the rate, and the energy transfer that's there. So physical chemistry tends to have a little bit of more mathematics in it. It also tends to take a look at different numbers and how they relate, so you can start to see like the rate of something, so beats per minute, for instance, and the energy transfer that can happen within different substances, and how things maybe go from solid to a liquid, like say having an ice cube melting down into water, or vice versa. So you can see here, just as an example, we've got physical chemistry. Physical chemists might study factors that affect, say, breathing rates during exercise. Or organic chemistry. Athletes inhale chemicals developed by organic chemists, and they control symptoms such as asthma. Analytical chemistry. They develop tests to detect chemicals in the blood. Tests can help show if organs in the body are working properly. Then we've got inorganic chemistry. They might explain how a lack of calcium can affect the growth and repair of bones. And biochemistry, they might study how the energy is used for the contraction of muscles that is produced and then stored in the body. So all different aspects kind of related to a specific example, but they're all connected and work together kind of for the greater good. So there are two different fields of chemistry. You've got pure and applied chemistry. So pure chemistry is the pursuit of chemical knowledge for its own sake. There may or may not be an immediate practical use. So they're trying to push the limits of our understanding of chemistry and what it is, different compositions of things. They're not quite concerned with how can society use this. They're just concerned with let's move on and push chemistry forward as far as it can go. So in that case, you're thinking like your researchers and that kind of stuff. Applied chemistry has this practical goal or this application in mind, and I've got some sticky notes that are here. Those sticky notes, if you've never really thought of sticky notes before, they have kind of a glue substance on the back, and so the company that makes them is 3M, and in the late 60s, early 70s, there was a scientist that was working in that area in 3M and was trying to figure out this really strong adhesive. He was trying to come up with a chemical compound that could really make a really strong adhesive. And the only thing that he could do is he could come up with this, accidentally kind of came up with this weak compound that could be reapplied, and you could stick it on a surface and take it off and stick it on a surface again. And so over time, that idea then went to somebody else who basically could see the connection of taking pieces of paper and being able to stick it on a surface, and the idea of sticky notes kind of was born from there. But it was really an accidental discovery, but had a severe applied chemistry application to it, because I mean we see post-it notes pretty well everywhere now. So why study chemistry? Chemistry can be useful in explaining the world around us and preparing people for a variety of different career opportunities. So as you can see here, chemistry can go into all kinds of different fields. When I think about kind of your three main sciences when you get to high school level, chemistry, physics, and biology, the chemistry unit itself, or chemistry topic itself, kind of goes in the middle. It relates itself to many different things because of how it describes compositions of chemicals and how it can show reactions and what happens, and it works in many different ways. So yeah, that's part one, basically covering through chapter one. It just is a light introduction, and we'll go on to the next part.